Today we are going to discuss about the topic light. Okay.
Okay.
Okay. First, let us know what is meant by light. It is a form of energy which enables us to see the things around us. It is a basic definition of light, right? Also, we can define light as it is an electromagnetic radiation ranging between the wavelength of about 400 nanometer to 750 nanometer. This is the range of light in electromagnetic radiation. Then what is meant by electromagnetic radiation? It is nothing but it is a form of energy which travels in space as a oscillating electric and magnetic fields. As oscillating electric and magnetic fields. Here, light is a form of energy which enables us to see the things around us. It is a basic definition. We can also define light as it is a electromagnetic radiation ranging between the wavelength of about 400 nanometer to 750 nanometer. Here, nano stands for 10 raised to the power 9 minus 9. Okay. Electromagnetic radiation, what it means? Electromagnetic radiation. It is also a form of energy which travels in space as a oscillating electric and magnetic fields. Clear? Here, the speed of light is given by c is equal to 2.99 into 10 raised to the power plus 8 meter per second. This is the speed of light. This can round it off and we will write this as 3 into 10 power plus 8 meter per second. This is the value of speed of light. The speed of light is maximum in vacuum. Okay. It is the highest speed attainable in nature. What is the lowest, where we can attain a lowest speed, which is nothing but in diamond. Okay. Why? Because this is a optically dense material. Clear? In diamond, the speed of light is lesser. In vacuum, the speed of light is greater. Clear? This is about speed of light. When the light, if the light travels in a straight line, then we consider this as a rectilinear propagation of light. If the light travels in a straight line, then it is considered as rectilinear propagation of light. Where it is where we can observe this rectilinear propagation means formation of a shadow, and the pinhole cameras works on this principle. Cleared? This rectilinear propagation of light, we can observe this in formation of a shadow, and a pinhole cameras works on this phenomena, rectilinear propagation. Cleared? The light traveling along a straight line is considered as a ray of light. When the light travels in a straight line, this is considered as ray of light. How can we represent this ray of light? It is nothing but a straight line with an arrow. This is ray of light. The group of light rays, this is a single ray of light. The set of or a group of light rays is considered as beam of light. Clearly, we can say that we have three types in beam of light. Here, let us consider a group of rays. Here, this is a ray, right? This is a ray. Let us consider a set of rays, which is nothing but this is one ray, and this is other, and this is another, and this is other. Okay, here we have a set of rays, group of rays. This group of rays is considered as parallel beam of light, because one ray of light is parallel to other and the other is parallel to other, right? So this set of rays is considered as parallel beam of light. In the same way, we have two other different types in beam of light. Let us know that here the rays coming from different directions are meeting at a single point, which is nothing but they are converging to a single point like this. The rays coming from different directions are converging at a single point. So this is considered as convergent beam of light. Are you getting, Santosh?
Yes, ma'am.
Yes. In the same way, we can define divergent beam of light. This is reverse of this convergent beam. That's it. The rays spreading from a single point. If this is a point, the rays spreads in a different directions like this. This is a divergent beam of light. Clear? These three are different types of beam of light. One is parallel beam of light, other is convergent, and another one is divergent beam of light. This is about three types of beam of light. Here the light exhibits different phenomena such as reflection, refraction, interference, diffraction, polarization. These are all the phenomena that exhibits by light. In this class, let us discuss about reflection and refraction, okay? Now, let's move on to the next topic, that is reflection. Okay, first let us know what is meant by reflection. When the light falls on a highly polished surface, it gets reflects back. This phenomenon is known as reflection of light. Okay, let us understand this by a ray diagram. First, let us draw an highly polished surface. Let us consider this is a highly polished surface. Here, the shaded part is considered as a opaque surface. The downward surface of this surface is considered as opaque. Opaque is nothing but it is a surface where light can't travel through. Clear? And this upper surface is a polished surface.
Okay.
Got it, Santosh?
Yes, ma'am.
Yeah. Now let us draw a normal to this surface. Normal. I am indicating this by a dotted line. This is a normal drawn to the surface. Now, let us draw an incident ray. This is an incident ray. This is the direction of the ray. We have to write a arrow symbol for the rays. Okay, it indicates the direction. Clear? This is an incident ray which is falling on the highly polished surface. Then what happens according to reflection? It gets reflects back to the same surface like this. Got it? This is the incident ray, this is the reflected ray, and this is the normal ray drawn to the surface. Okay? From this ray diagram, we can understand that when the ray of light falls on a highly polished surface, it gets reflects back. This phenomenon is known as reflection. Okay? Here we can measure the angle between the incident ray and the normal ray. This angle is nothing but angle of incidence. Okay, and this angle represents the angle of reflection. Clear? Angle of incidence is nothing but the angle between the incident ray and the normal ray drawn to the surface at the point of incidence. We cannot draw a normal wherever we can. We have to draw the normal at the point of incident only. Got it? Here this represents angle of incidence, and angle of reflection is nothing but it is the angle between the reflected ray and the normal drawn to the surface at the point of incidence. Cleared?
Yes, ma'am.
Yeah. We have two laws for this reflection process to occur. What are all these two laws? Let us discuss the laws of reflection now. Laws of reflection. We have two laws. One is the incident ray, the reflected ray, and the normal drawn to the surface should lie on the same plane. What it means? The incident ray, the reflected ray, and the normal drawn to the surface should lie on the same plane. It is a same plane is nothing but a two-dimensional surface, right? Where we can draw the ray diagram, we have drawn the ray diagram in a two-dimensional surface itself, right? Yes, in the incident ray, reflected ray, and the normal drawn to the surface should lie on the same plane like this. Here, incident ray, reflected ray, and the normal ray, these three rays are lying on the same plane. This is the first law of reflection. Clear? And the second law is, I have represented angle of incidence and angle of reflection in the ray diagram, right? Second law, is nothing but the angle of incidence should be equal to the angle of reflection. The angle between the incident ray and the normal ray is equal to the angle between the normal ray and the reflected ray. That is the second law of reflection. This is about laws of reflection. Let's move on to the next thing, that is mirror. What is mirror? It is a smooth, highly polished surface which reflects most of the light falling on it. That surface is considered as mirror. Okay, it is nothing but a smooth surface which reflects most of the light which is falling on it. This is considered as mirror. Here, let us consider one special case. Now, let us draw a smooth surface. Okay, and this downward surface is nothing but opaque. Okay, this upper surface is a not upper surface is a reflecting surface. Lower surface is opaque. Okay. Now let us draw a normal to this surface. This is the normal ray. If there is no angle between the incident ray and the normal ray, which is nothing but when the incident ray falls normally on the surface like this. This itself is the incident ray. Then what happens to the reflected ray?
It passes through the incident ray.
Yeah, it retraces its path like this. It passed through the same path like this. Okay, this is important. Okay, let's move on to the next thing, that is, this is about the reflection process in plane mirrors. Then what about in spherical mirrors? It is quite different. Let us discuss that. Reflection at spherical mirror. Okay. First, let us know what is meant by spherical mirror. Spherical mirror is nothing but a part of the hollow sphere with which one part is opaque and the other part is reflecting surface. Here we have taken a mirror. Mirror means one part is opaque and the other part is other surfaces. It should be reflecting surface, right? But spherical, what it means, spherical mirror means it is a part of a hollow sphere. Let us consider a sphere, hollow sphere. Let us consider this is a hollow sphere. Spherical mirror is nothing but it is a part of a hollow sphere with which one part is opaque and the other surface, one surface is opaque and the other surface is
Reflecting.
reflecting. Let us consider this shaded part is opaque. Okay, this inward surface is reflecting. This is reflecting surface. Okay, this also we are having two types of spherical mirrors. One is concave spherical mirror and the other is convex spherical mirror. Have you got this point, Santosh, about the definition of spherical mirror?
Yes, ma'am.
Yes. Okay. Let's move on to the next thing, that is concave and convex spherical mirror. We know that it is a part of the hollow sphere. Let us write a hollow sphere. Okay. This is a part of hollow sphere with which one part is opaque and the other part is reflecting. Here, what happens? The reflecting in concave spherical mirror, the reflecting surface of the sphere is towards the center of the sphere. That's it. Okay. If this is a sphere, this is the center of the sphere, right? This is a sphere. Let us consider this is the center of the sphere.
The opaque will be
What it,
towards the center.
yeah, reflecting surface is towards the center of the sphere. The outward surface is opaque for this concave spherical mirrors. Got it?
Yes, ma'am.
This is, let's consider for convex. Then what happens to the convex? Let us consider a part of the spherical mirror. Here, this is the center of the sphere. In convex spherical mirror, the center of the sphere is away from the reflecting surface. Here what happens? This inward surface is considered as opaque. That's it. Got it?
Yes, ma'am.
Yes. Let's move on to the next topic. This is about mirrors. Different types of spherical mirrors. Let's move on to the next thing, that is refraction. Okay.
Yes.
Refraction. Okay. Let us define what is meant by refraction. When the ray of light travels from one medium to other medium, the direction of the ray changes. Okay. This phenomenon is known as refraction. Now, let us draw a ray diagram for this. Let us draw a surface which is separating two media. Let us consider this is a surface which is separating two media. Let us consider this is a rarer medium which is lesser refractive index, and this is denser medium which is more refractive index when compared to rarer. Okay. This is a surface separating two media. Here also we have to draw a normal to the surface. Now, let us take an incident ray which is falling on the surface. Then what happens when the ray of light travels from one medium to other medium? The direction of the light changes. Okay. Here, what happens from when the ray of light travels from rarer medium to denser medium? This is the incident ray, this is the normal ray, and this is angle of incidence. Okay. When the ray of light travels from rarer medium to denser medium, what happens? The refracted ray bends towards the normal like this. Okay. This is refracted ray and this is angle of refraction R. Clear? This is a ray diagram for when the ray of light travels from rarer medium to denser medium. When the ray of light travels from denser to rarer, the ray diagram is different. Let us understand that. Let us consider a surface separating two media. This is denser medium and this is rarer medium. Okay. Now, let us draw a normal to the surface like this. According to refraction, when the ray of light travels from one medium to other medium, the direction of the ray changes. Okay. Here, let us consider an incident ray which is falling. Okay. This is an incident ray. This is the normal ray. Here, what happens? The incident ray is traveling from denser to rarer medium. Then what happens to the refracted ray? It bends away from the normal. Okay, like this. It bends away from the normal like this. This is the angle of incidence and this is the angle of refraction. Clear? When the ray travels from rarer to denser, the refracted ray bends towards the normal. When the ray of light travels from denser to rarer medium, the refracted ray bends away from the normal. Clear? Without this medium, the incident ray would have passed through like this, right?
Yes, ma'am.
Would have passed through like this. But in the presence of this medium, it has taken its different direction. So, this angle is nothing but angle of deviation D. Clear? Okay,
Yes,
this is nothing but angle of deviation. What it means, angle of deviation? It is the angle through which the direction of the incident ray changes.
yes.
Nothing. Yes, angle of deviation is nothing but it is given by angle of incidence minus angle of refraction for when the ray of light travels from rarer to denser. Clear?
Yes,
Have
ma'am.
you got this point about deviation?
Yes, ma'am.
Okay. In this case, it is different. Why? Because here the ray of light is traveling from denser medium to rarer medium, right? Here, without this medium, the incident ray would have passed through like this, right?
Yes, ma'am.
Here, this angle represents the angle of deviation. In this case, we can take angle of deviation as R minus I. Cleared? Have you got this point?
Yes, ma'am.
Yes. In general, we'll write this angle of deviation as I difference R. This is a formula to calculate angle of deviation. Okay.
Yes, ma'am.
Here also we are having laws of refraction. Here the first law of refraction is same as that of reflection, which is nothing but, can you tell me the first law of reflection?
The incident ray and the reflected ray refracted ray should refract at the same plane.
Yeah, the incident ray, the refracted ray, and the normal
Normal ray.
and the normal ray should lie on the same plane. Okay, drawn to the point of incidence. That point is important.
Okay.
We cannot draw normal wherever we can, right? We have to draw a normal at the point of incidence. Okay, this is the first law of refraction. And the second law is sine I by sine R is equal to constant. Sine of angle of incidence to the sine of angle of refraction is always a constant value. Okay, we can take this constant as sine I by sine R is equal to n. We can also call this formula as Snell's law. This sine I by sine R is equal to n is taken as Snell's law. Okay, here this is n is nothing but the refractive index of one medium with respect to other. Okay, this refractive index of medium 1 with respect to, let us consider this is medium 1 and this is medium 2. How can we write this refractive index with respect to one another? We can write this as refractive index of medium 2 with respect to medium 1 is equal to sine I by sine R. In the same way, refractive index of medium 1 with respect to medium 2 can be taken as sine R by sine I. Got it? This is nothing but the refractive index of one medium with respect to other. This n21 indicates the refractive index of medium 2 with respect to medium 1. That is taken as sine I by sine R. This n12 represents refractive index of medium 1 with respect to 2. That is nothing but sine R divided by sine I. Okay. This n is equal to sine I by sine R is a Snell's law. Do you have any doubts, Santosh?
No.
Can I ask you some questions?
Yes, ma'am.
Yes. Can you state the refraction process?
Yes, ma'am. What's the question, ma'am?
Refraction. What is meant by refraction?
It is the process where the light passes through a single plane, where the incident ray.
Just look at this ray diagram and explain. That itself is your answer.
It is when the incident ray passes through the plane and
not a plane. Travels from one medium to another.
Travels from one medium to another and changes its direction.
It changes its direction. This phenomenon itself is known as refraction. In the refraction process, we came across two different ray diagrams. One when the ray travels from rarer to denser, and the other is when the ray travels from denser to rarer. Clear?
Yes, sir.
Yeah. This is about